Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, hello everyone. A very good evening to everyone present here. Can I quickly have a plus one in the chat box and so that I can know your name who all are attending, and at the same time, can you please confirm that I am properly audible and visible so that I can very quickly start with my session? Yeah. You will find the link of the Jamboard session, that is the slides for today's discussion, in the description of this video. Yeah, I hope the video is properly visible now and there is no lag. And I see quite a lot of students who have joined with me live in this session. I would request you all to kindly do a plus one in the chat box that I can know your name, and then we will very quickly start. Okay. In the meanwhile, I am also sharing my screen and just give me a pointer that I am properly audible, visible, and my screen is also visible. Okay. Hello, Sam. How are you? Hello, Suraj. How are you? Hello, Kunar Kumar. How are you? Yeah. So, hmm, yeah. Yeah. Apart from that, I would also request you all to kindly hit the like button for this streaming and subscribe to our channel as well. Okay. So, this will be a session on essential maths, and let me give you a small introduction about this series. It will just take 2 minutes, and then we can start. This series is focused upon preparing you all for your SDE interviews. So what we are doing basically, on every session, we are taking up a particular topic, and then I am discussing all the important and relevant concepts related to that particular topic, which are very frequently asked in interviews these days. Okay. This started last month, and we have covered topics like uh, binary search, bits manipulation, and today we are doing essential maths. And tomorrow we will also be doing the same topic. After that, we will be doing with stacks and queues. And till the length of this entire series, I am very much sure that you will be equipped with all possible important concepts and questions which are very frequently needed in from interview point of view. Okay, so I am sharing my screen now. Yeah. The link of this Jamboard session is already present in the description of the chat box of this video. Okay. So meanwhile, I would request other student as well to do a plus one so that I can know your name, and I would request you all to kindly make this session interactive so that it is enjoyable for me as well and for you as well. Okay. So hello Suraj, hello Abhishek. So yeah, Can I just have a plus one in the chat who all are preparing for their upcoming interviews? Or we are in the month of February, like we are in the month of March almost, and if you are in your pre-final year or if you are in your second year right now, you will be having your interviews from the month of July and August, I suppose. So, hello Santosh. No need to spam Santosh. I can see your chat. I can see your comment. Okay. Okay, then let me start with the discussion for today's topic. And before that, let me introduce myself. So, my name is Gaurav Kumar Shaw. I'm writing my name on the screen. Okay. My name is Gaurav Kumar Shaw. And presently, I am in my pre-final year at IIT Kharagpur. That is third year at IIT Kharagpur. And I'm also an upcoming intern at software engineering intern at CureFit. And apart from that, I'm also a mentor at GeeksforGeeks. And I have been mentoring students since a quite a lot of time. And I've got a real good expertise in delivering content and helping students prepare for their interviews and their assessments. Okay, so yeah, this was about me. Hello Ayushi, how are you? Hello Shirsha. Okay, yeah. Yeah, so this was about my introduction, and so the topic for today is essential maths. Okay, so I would request you all to kindly attend the entire topic till the very end. And apart from that, today we will be discussing concepts like certain frequent concepts like GCD, LCM, and binary exponentiation, which are very frequently utilized while solving problems. So the important thing about maths is that questions from maths rarely come up in interviews. Okay, so we'll wrap this in two sessions only. So, but the idea is that in interview, a different question will be given based on DP or maybe on graph, which will require the concepts of mathematics. Okay, so interviewer will not directly ask you the concepts of mathematics. In fact, it will be concealed in some other problems. Okay. So first of all, I'm listing down all the important topics which are necessary from interview points of view. So there is something called as binary exponentiation. Then okay, and there is also concepts of GCD and LCM. Apart from that, there is a modular arithmetic concepts as well. Okay, and then how do you, this is basically how to compute e to the power b, but in this case there are other modifications of this problem only. There is something called as fast multiplication. Okay, then there are remainder theorems like the Chinese remainder theorem. And in fact, the Chinese remainder theorem and other remainder theorems are not necessarily asked in interview. They are from online assessment point of view. If you are doing into competitive programming, you will be frequently coming across this Chinese remainder theorem. But something very important are prime numbers. Okay, prime numbers and factors and divisors. Okay, so these are some of the important topics. Then there is something in prime number. You will find the concept of sieve. Okay, so sieve, the application of sieve are very widespread in a lot of problems of maths and other areas of data structures and algorithm. So having a hold on this topic will actually help you. So today we will be mostly focusing on binary exponentiation and some parts of GCD and LCM. And in GCD, mostly Euclid's algorithm. So I see quite a lot of students have joined in the last few minutes. So I would request you all to kindly do a plus one in the chat. Yeah. Yeah, before we begin with our topic of discussion today, there are a few things that I would like to say is that There is a complete interview preparation course link which is attached with the description of this streaming, and at the same time pinned on the comment box itself. So you can definitely check that out. It is an extremely well crafted course for your interview preparations. And if you are preparing for your upcoming interviews or just want to revise the core concepts, that particular course will be very helpful. So all the important topics are neatly packed in that course. Okay. And apart from that, yeah, and we are also having a live mock DSA mock interview session on this very channel itself on every Saturday at 10 p.m. So, in case you are interested to be a part of that session, you can fill up the form in the description. We will arrange a mock interview session for you. Okay. So, yeah, let us begin with today's session then. So, how many of you all do know about GCD and LCM? Okay, and I hope everyone knows about GCD and LCM. So I don't want to spend a lot of time on this because I have got other important topics to discuss. So the full form of GCD is greatest common divisor and LCM is lowest common multiple. So let's say you're given two numbers A and B. This is 4 and this is 12. Let's say. So what you will do first is prime factorize 4. So inside 4 you can find 2 to the power 2, and inside 12 we will find 2 to the power 2 multiplied with 3. So GCD basically takes what is exactly the common divisor, which is basically divisible by both 4 and 3, and at the 4 and 12, and at the same time it is the greatest amongst all. So how will you find that? So by just the definition of the terminology, if you take the common powers of the two numbers, in that case you will end up with GCD. So from here example, we see there is 1 2 common, and there are 2 times 2 are common. So 2 to the power 2 is a common factor between both 4 and 12. In that case, we can say that 4 is the GCD of 4 and 12. And what would be the LCM? LCM is the lowest common multiple, or a particular number which is a multiple of both 4 and 12, and it is lowest of all possible numbers. Okay. So how will you find that? In that case, what you will do, you will take the for LCM also you will take the common factors. But apart from taking the common factors, you have to make sure that you take all possible unique factors of that number. For example, in this case, we have got 4 as common, so you will definitely take 4. But here you also have 1 3. Okay, you cannot skip that. You have to take 3, because if you are taking 3, that is the case. 12 is a multiple of 12 as well, and 12 is a multiple of 4 as well, and 12 is the lowest common multiple. A multiple which is multiplied a particular number. If you multiply with both the numbers, you will get that particular number, and it is the lowest of all. Okay, so this is the idea of lowest common multiple. Okay, Suraj, that's great. So there is a very interesting result related to HCF and LCM, and that is equal to A into B divided by the LCM divided by the GCD will be equal to LCM. So if you are given any problem and you know the values of A and B, and you already also know the value of the GCD of A and B, so you can just multiply these two numbers to get the LCM in O of 1 operation. Okay, so basically the product of the GCD and the LCM is equal to basically this product of the given two numbers. Okay, so this was from this slide. I am sure you all don't have any doubts here. This was very basic. So let's move to the next part. What is Euclidean algorithm? Does anyone know Euclidean algorithm? Um, just a heads up that Euclidean algorithm is not something difficult or something complicated. It is in fact the very common process which we all have learned in our school days. When we were in class 8 or 9, we have learned about how to find the GCD. Okay, so yeah. So like if someone is telling you how to find GCD by long division method, that is nothing but Euclidean algorithm only. Okay. Okay, Suraj. So you do not know Suraj and Mahesh. So you all do not know Euclidean algorithm. Okay, no worries, Suraj and Mahesh. I will teach you. But in fact, nothing to be worried about Euclidean algorithm. Is just the process is quite simple and it is very basic. Okay, so so what exactly is a Euclidean algorithm? So Euclidean algorithm is basically an algorithm that will help you find the greatest common divisor between two numbers A and B. Okay. So let's suppose you are given two number. You are given two number 12 and 18, and the GCD happens to be 6. Okay. Hmm. And yeah, GCD happens to be 6. Now, what exactly is the process of finding the number 6 is devised in this Euclidean algorithm. Before I begin, let me tell you that when we are dividing a number by another number, let's say I am dividing a number A by a number B. Okay, so in long division method, if you remember during your childhood days, you must have done this long division method. Okay, where you try to find a factor which will try to cover the value A. Okay, so this part, whatever was written here, is called. We used to call this divisor. I've already written here. The denominator part is often used to called divisor, and whatever was in the numerator, we call it dividend. Okay. Now, after we divide the dividend by the divisor, whatever extra value that we get is called the remainder. Okay. So these three terms should be clear: divisor, dividend, and remainder. In Euclid algorithm, what happens? Since you're finding two numbers, you have to make sure one number is a dividend and another number is a divisor. Okay, you have to begin your problem by that approach. So let us say that 18 is the dividend and 12 is the divisor. So now you will divide the dividend with the divisor. So you divide 18 with 12. The nearest factor that can actually help in division is 1. So 12 multiplied with 1 gives you 12. Now the remainder is the extra value, that is 6. So 6 is the remainder. So this is the first step of the division. You obtained a remainder. Now what does the Euclidean algorithm say that in order to find the GCD between two numbers while you are dividing, after you get a remainder, make the remainder equal to the divisor and the divisor equal to the dividend. Okay, so make the remainder is equal to the divisor and the divisor equal to the dividend. Okay, just a minute. Okay, so is that clear? So Euclidean algorithm say, let me repeat once again, the remainder will become the divisor and the divisor will become the dividend for the next step, division step. Okay, so this was about Euclidean algorithm. Okay. So now what is happening here? The 6 which we have obtained in the remainder will become the divisor for the next area. And this 12 will come here as a dividend. So now 12 is my dividend, 6 is my divisor. And now I will again do a division. So 6 multiplied with 2 will give you 12 and the remainder is equal to 0. So when a remainder becomes equal to 0, you have to stop your division process because the Euclidean algorithm says that keep on continuing with the division until and unless you find a remainder equal to 0. So whenever remainder is equal to 0, whatever divisor you have is your GCD. So at the second step, if the remainder became 0, so my divisor is the GCD. So GCD is 6. Got it? Any doubts till here? Any doubts in Euclidean algorithm? Hello Suraj. Hello Sachin. Hello Shirsha. Hello Ayushi. Are you there? Hello Mahesh. Yeah, so we have quite a lot of audiences watching me right now. I would request all of you to kindly like this streaming session and at the same time do a +1 in the chat box as well. Okay. So this was about inline. So there is also something called as inbuilt function in C++ that will help you compute the GCD. Can anyone in the audience tell me what exactly is that inbuilt function? Yeah, thank you, Suraj. So, can anyone tell me what exactly is that inbuilt function that is inside the C++ library that will help you compute the GCD? And also tell me what exactly will be the time complexity of Euclidean algorithm. Tell me both of these. Okay. An inbuilt function and the time complexity, what I just explained. Okay. Anyone? Anyone in the audience? Hello Suraj, hello Mahesh. Yeah, Malika, I'm asking that what exactly is a user-defined function? Tell me the name of the user-defined function. Let me share my screen once again. I just by mistake clicked on not sharing. Okay, there is a function called underscore GCD, underscore GCD. Okay, so I am also typing this thing in the chat box itself. So you can read about this on the internet. And okay, so this is a function underscore GCD a comma b. So this is an inbuilt function in the C++ library that will help you compute the GCD quickly. Okay. So, but this function also takes a similar algorithm. And tell me, what exactly will be the time complexity for Euclidean algorithm? Just think in terms of what I just explained to you. Okay, that just think like how many steps is this division process taking place? Okay, we have a number 18. 18 is the number consisting of two digits. So for a two-digit number, how many steps will it take to get the remainder equal to zero by this process? So anyone? Hello, Malika. Would you like to have a guess? Hello, Sachin. Hello, Suraj. Suraj, since you did not knew about this inbuilt function, I wrote it in the chat box. You can read a GFG article on internet about this. This is actually a very handy function. Okay, like in a lot of problems you have to take the GCD. Okay, and you cannot type the Euclidean algorithm every time. So this comes handy in those type of problems. Okay, yeah. So Sachin, hello Sachin, how are you? Yeah, yeah. Can you tell me the time complexity of this Euclidean algorithm? Hmm. So as I was saying that the division of 18 required you to complete in two steps. So what does this mean basically is that so let's say I have an integer data type. An integer data type contains 32 digits. Okay. So the number whenever you're trying to find it is getting it will only proceed the number of digits it has. Okay. So the complexity will be equal to log of log n. Okay. The because the number of bits is basically the logarithm of the data type that you have. Okay, so Euclidean algorithm proceeds by a logarithmic time complexity. Okay, so know this. So let's move to other topics. We cannot spend a lot of time here. Yeah. So what about the code for this? Okay, we have so this is the code basically of the implementation of Euclidean algorithm in the form of recursion. Okay, so yeah. So what is happening here is that we have a function called GCD. It is taking two variables a and b. As I mentioned that whenever we are trying to implement Euclidean algorithm, we are dividing a by b. Okay. So a is nothing but the dividend. Okay. And b is nothing but the divisor. Okay. So this function is taking the yeah. So I was saying that this function was taking two values a and b, and it was returning the GCD. So what it became? So let's say this was a dividend and this was a divisor. So as I said, the remainder of one particular step of division will become the divisor for the next step. So that is why I am recursively calling the same function with the parameters b and a mod b. So a mod b is nothing but the remainder. Okay. So this is becoming divisor and b is becoming the dividend for the next step. So this is the base condition of the recursion. So, what exactly will be the base condition? As I've said, Euclidean algorithm will stop at the moment when the remainder, which is a mod b, equal to 0. So, if the remainder is becoming 0, we will just return the value b. Okay, it means that b is the GCD for that number. Okay, so whatever is my divisor at that point of time will become my answer. Okay, for example, if you just run this function with 12 and 4, you will get 4 as the GCD, and if you run 18 and 12, you will get 6 as the GCD. Now, since we already know GCD, we can very easily calculate LCM also by the formula GCD into LCM is equal to A into B. Got it? Yeah, yeah. So Sachin, did you understood it? Suraj? Hello Malika, are you there? Hello Mahesh, are you there? So the students who have joined later, I would request you all to kindly like the streaming as well as subscribe to our channel. We are having a session called SD Preparation Interview, and this session will mostly focus upon preparing for your interviews. Okay, so so what I'm basically doing is that every week I'm taking up a topic and discussing all the important concepts related to that topic with the help of practice problems as well. And today we are discussing essential mathematics. Okay. And apart from that, we also have a dynamic programming session going on. In fact, it got completed last week. We also have a live mock DSA, which we run on every Saturday at 10 p.m. Okay, so if you want to have your live mock interview session scheduled with any of the mentors at Geeks for Geeks, you can fill up that form in the description, and we'll help you schedule that on this very channel itself. So in that, what will happen? You will be interviewing live on this channel, and an entire internet audience will be watching you live solve the questions. Okay. So if you, in fact, I would recommend you all to kindly do that because taking a lot of mock interviews will eventually help you in your interview preparation. Okay, thank you, Mahesh. Mhm. So as I just previously asked that there are a lot of students who are preparing for their upcoming interviews. So how many of you are in second year right now? Second year of your college, of your BTech program or your engineering program, and you would be having your interviews in the next 4 or 5 months. Okay, so this is a perfect opportunity for those kind of students. So let me discuss binary exponentiation now. Okay, so is there anyone who already know about binary exponentiation? As I have already mentioned, this is nothing but an algorithm to calculate or compute a to the power b. Okay. Hello Mahesh, thanks for understanding. Meanwhile, Mahesh, you can check out the course link which is attached with the um, first comment. That is a complete interview preparation. And if you are preparing for that, you can definitely check out that course. It's an extremely well crafted course for preparing for your interviews. Okay, so let us continue then. Yeah. And in case if you have any doubt, you can ask in the chat box. And I would request you all to kindly keep the session as interactive as possible, so that it becomes enjoyable for you as well and for me as well. So let's have a look into binary exponentiation. So, as I said, it is an algorithm to calculate a to the power b. Okay. So, for example, if you want to calculate the 2 to the power 3, you will get 8. And there is also a special function called power function in which you pass the parameters and you get the answer 8. Then, why exactly do we need to learn a concept called binary exponentiation, and why does power function will not help us calculate a to the power b? For 2 comma 3 we will get 8 by both the methods. So why learn a new technique and instead not use this function? Can anyone tell me what is the importance of binary exponentiation which is not satisfied by the power function? Mahesh, can you tell me the where does the power function exactly fails? Hello Sachin, hello Suraj, hello Malika, hello Mahesh, hello Ayushi, hello Santosh, hello Abhishek. Those who are watching me live, I would request you all to kindly keep the session interactive by replying to my questions in the chat box. Okay, Sachin, no worries. I will teach you right now. So, Sachin, okay, Sachin and my since you all do not know about this, I would recommend you all that after this session, kindly review this problem by going to GFG articles on the same, because this is an extremely important concept and these are very frequently used in interviews in questions as well. Okay, so knowing this is very important. Okay, so I was saying that why exactly do we need power function, and why exactly do we need binary exponentiation, and that power function is not sufficient. So the idea here is that a power function returns answer in double form, and double is actually a data type that will help us store decimal numbers. So it can store large numbers, but actually these large numbers are not accurate. Okay, so but a particular number, if I say 10 to the power 20, and double will basically not able to store such a large number. It will be able to store such a large number, but not accurately. Okay, so there will be precision errors. Okay. But whenever you are doing competitive programming or you are solving problems, so you cannot afford to make mistakes like such, because whenever you are solving a competitive programming problem or submitting a problem in an IDE, so what happens? The answer gets matched exactly with a particular answer. So any form of mismatch will give you a wrong answer. Okay. So that is the reason we do not rely on binary. Do not rely on this power function. Instead, we have special functions called the binary exponentiation. Okay, so we will discuss that. So what exactly binary exponentiation says? So for example, let's say you are supposed to calculate a to the power b. So why not run a loop and multiply a with itself b times? Okay, so the complexity will be linear O of n. Okay, this also is a good idea, right? Why don't we rely on this type of a linear function to compute a to the power b? Yeah. So as I see, quite a lot of people are live with me right now. I would request you all to kindly like this session and also do a plus one in the chat box. Okay. So my question is that yeah, because as I was asking that why is it necessary to have a binary exponentiation function and not rely on running a loop and multiply a b number of times to get a to the power b in linear time complexity. Okay. So the answer would be that since this finding a to the power b is a very frequent requirement, and whenever we are doing a problem, let's say we are running a loop for O of n, and we need to find a to the power b. So we are doing a linear operation inside a loop. So this will take a quadratic operation. So this is actually very costly doing it in linear operation when there are an algorithm which will help you do it in very quickly than this. Okay, so definitely we do not do like this. So, what we will do basically decrease the time complexity from linear to logarithmic binary exponentiation used. The time complexity of binary exponentiation is logarithmic. So, let me show you how. So, let's say we want to compute the power 2 to the power 16. In this, a is equal to 2 and b is equal to 16. So, binary exponentiation takes use of divide and conquer algorithm to solve this question. How so? So let's say a is equal to 2 and b is equal to 16. So what it will do first, in order to compute 2 to the power 16, it will compute 2 to the power 8 and 2 to the power 8. Okay. I hope everyone is understanding with me. Okay, I suppose I was muted. Really sorry for that. So yeah. So what we are basically doing is that since we have 2 to the power 16, so 16 is in the power. So what we will do, we will divide 2 to the power 16 by 2, that is 16 by 2. So for getting the answer of 2 to the power 16, we will find the answer of 2 to the power 8 and 2 to the power 8. Then again for 2 to the power 8, we'll find for 2 to the power 4 and 4. For 2 to the power 4, we'll find 2 to the power 2 and 2. And for 2 to the power 2, we already know 2 and 2 will be the answer. So we multiply these value, get this. Again multiply these two together, get this. Multiply these two together, get this. Multiply these two together and get this. So in a total of 4 steps, we are computing 2 to the power 16. Okay. So and we have basically skipped a lot of other values at 2 to the power 3, 4, 3, 5, 7, 9. Okay. So this binary exponentiation uses the concept of divide and conquer algorithm for finding the power and then combining. So what will happen if we have odd number of powers? Let's say 3 to the power 13. In that case, what we will do, we will write 3 into 3 to the power 12. Now 12 is even. So if it is even, we can easily divide the power by 2. Okay. And if it is odd, like 3 to the power 3, we will write 3 into 3 to the 3 square. Okay. So if it is an odd power, we will just take one number before that and then we will convert it into even power. Okay. So I hope it is clear till now. Hello, is my voice properly audible? Mahesh is saying my voice is not coming. Is that so? Hello, I hope my voice is properly audible. I just tested it. Can anyone please confirm in the chat box that I am properly audible? Okay, Utkarsh, thank you very much. Yeah. So we were thinking. Yeah, we were discussing about binary exponentiation. So as I just explained you the concept of binary exponentiation, we want to write a recursive formulation that will help us solve this question. So let us say that we have a function called f, and that is taking two parameters, a and b, and it is computing me a to the power b. So if b is equal to even, then we can say that a to the power b is nothing but the same function, but for a and b minus 2, because if it was 2 to the power 16, we were basically doing 2 to the power 8 into 2 to the power 8. So f of a comma b by 2 multiplied with f of a comma b by 2 if b is even. And if b is odd, we are taking one a out of here and then we are doing f of a comma b by 2 and f of a comma b by 2. For example, if it was 2 to the power 17, we would have done something like this: 2 into f of uh, 2 comma 17 by 2 into f of 2 comma 17 by 2. 17 by 2 would be 8 and this would also be 8. So this is 8 into 2 to the. Okay, so I hope everyone understood it, how we are writing this two expression. So these two expression will help us solve the develop a recursive code. So this is a recursive code for this, and we are calling this binary exponentiation recursion. So if b is equal to odd, I just want to return a into f of a comma b by 2 multiplied with f of a comma b by 2. And then if b is even, we will return f of a comma b by 2 and e comma b by 2. No need to multiply it. So this is the code. So just identify, is there any error in this code? Can anyone in the audience tell me that is there any error you can find in this code? Utkarsh, is my voice proper now? Apology if my voice was breaking. So I'm just asking a simple question that whether is there any error in this code that I've just displayed? This is basically a recursive method to compute a to the power b using binary exponentiation. Okay. Utkarsh, can you identify the error? Okay, so the error would be that in this, what we were doing basically, we were identifying, computing this function f of a comma b by 2 multiple times. So this recursion will basically take a lot of space, and we don't want that. So what we can basically do, we can take a variable called res, and we will just compute this recursion. And if b is equal to odd, we will do this operation and do this operation. So multiplying is just a O of one time case, okay, and this is basically the recursion. So we are cutting down on the space complexity as well as the time complexity by just taking finding just computing this recursion once and utilizing it in the two expression instead of computing this recursion multiple times. So this was a mistake. So this will be the complete code for finding the recursion binary exponentiation to find a to the power b. The base case will be simple. If b is equal to 0, we will return 1. Okay. So this was about binary exponentiation, recursive formulation. Now, what about iterative code? Hmm. Can anyone tell me about iterative code? Utkarsh? Hello, Mahesh? Hello, Divya? So, iterative code is actually better than recursion, first of all, because it doesn't takes the stack space of recursion. And in fact, it also is based on the same concept. Okay. So, what we do basically here in iterative code, we write the power in the form of binary digits. For 13 will be represented in the form of 1101. Okay. So 1101 basically means that we are writing this as 8401. So 3 to the power 8, 3 to the power 4, 3 to the power 0, 3 to the power 1. So only we will compute the power only at that position we have 1. Okay, we will only compute the power at that positions only. Okay, so for hmm, let's look into this code. So binary exponentiation for iteration in take and end b. So initially you will take answer equal to 1. You will run a loop. Okay. The loop will basically take this value b, and if b is odd, you will multiply answer is equal to answer into a. Then you will do a square, and then you will divide b by 2. Okay, that is shift the bit. So this is a right shift operator which is shifting the bit. So in the first iteration, we have 1011. So we got 1 in the last position. So it means that B is odd. So we have 1 at the very last index, last bit position. So what we do? We have got A equal to 3 and answer equal to 3. Okay. Then we come here, we see 0. So we multiply 3 square and keep here 3. So 3 square into 3 will become 3 cube. Then 3 cube into, no, this will only be 3, because since we have 0, we do not multiply that. We will only multiply answer is equal to answer into a only at that position in which the bit is a set bit. It is 1. In this third position, we have a set bit. So that is the reason we are multiplying a with the previous answer. So 3 to the power 4 into 3 will give me 3 to the power 5. And finally, at the end, we have 1 here in the bit position. So we will multiply 3 to the power 8 into 3 to the power 5 will get us 3 to the power 13 as the answer. So this is the iterative code for solving this question. I hope this is clear. Yeah. Any doubts, anyone? Hello, Utkarsh. Hello, Mahesh. Hello, Akash. Hello, Sachin. Hello, Suraj. So let us keep our discussion till here. Tomorrow we will look into concepts like fast multiplication and prime numbers. Okay. So I would request you all to kindly solve a lot of problems for this. And yeah, other pointers I've written here that you have to take modulus in every step because you do not want it to overflow 10 to the power 9 plus 7. And you can also prevent overflows by writing long. Okay. So whenever you are multiplying two numbers, just write one LL multiplied in between so that it doesn't overflow while we are multiplying that. Okay. So this was for today's session, and I would request everyone to kindly like this session and at the same time subscribe to our channel. So those who have joined late, let me just repeat about this session. This session is primarily focused upon preparing yourself for you all for your SDE interviews, and if you all want okay, and if you have any kind of other recommendation that you would like us to deliver to you, so you can write that in the comment section, and we will definitely let our team know. And apart from that, we are also having a mock live DSA on every Saturday at 10 p.m. So we would request you all to kindly join that session. And in fact, if you are aiming for your preparation for your interviews, that will most certainly be helpful for you all. Okay. Apart from that, we also have a Yeah, we also have a complete interview preparation course, the link of which is in the first comments, and you will also find it in the description as well. So that is an extremely clean and concise and extremely well crafted course that will help you prepare for your interviews. And I would definitely request you all to kindly check out that course because it will most certainly be helpful for your preparation. Okay, so this was about today's topic. Let us meet tomorrow again. Today we discussed a few important topics like binary exponentiation and concepts involving yeah, how to find e to the power b, uh, and initially we discussed about GCD and LCM. So tomorrow we'll try to discuss about fast multiplication and other related concepts. Okay, so a very good night and thank you everyone.